Hello, students. This is your second set of notes that you need to take for your digital days. We are going to talk about this thing called kinetic energy. So as you go to your notes, you should have your second note page that we glued in. Should say kinetic energy definition at the very top. We're going to go through what kinetic energy is. We're going to go through these five examples, these five types, examples of them, pictures. And then you are going to wrap up by doing just a little bit of a review thing here at the end. And then we're going to revisit our skier question from the potential energy question. All right, let's talk about kinetic energy, everyone. Let's let this load up. So we talked a little bit about potential energy. This is stored energy. So think about something like pulling an arrow back. If you're holding it in place, it wants to be released, it wants to be moved, but you're holding it in place, so it's only storing that energy. Same thing with batteries. Batteries want to release the electricity that's inside of them, but the chemicals are storing them until you flip the switch or complete the circuit to let that energy flow. Now, potential energy is stored energy. Let's talk about the partner of it, kinetic energy. So potential energy is energy that's stored. Kinetic energy is energy in the form of motion. So anything that's moving, anything, whether it's really big or really small that we can't even see it, if it's moving or, as we would say, being used, it is kinetic energy. So in the last example, I talked about our roller coaster right here. As it goes up the hill, it stores that energy, but as soon as it makes it over and it starts falling and going really fast before it goes up again, it has kinetic energy. It has energy that's being used. Same thing like if you're skateboarding or longboarding down a hill or biking down a hill. As you're going down, you're using more kinetic energy because you are in greater motion. Now, kinetic energy is dependent on two things: an object's mass, so how much stuff is in it, which would relate to things like its weight, and its speed. How fast is it moving? Now, the greater the mass and speed, the greater the kinetic energy the object has. So let's say that this roller coaster, if I were to add on another car and increase its mass, how much stuff makes it up, it would have more energy as it heads down this hill. You could also think about it as who has more energy, or what has more energy: a little mini car going down the hill, or a motorcycle, or a giant semi. If we were to look at that example, the semi would have more potential energy. Even though the motorcycle might be able to go faster, the speed it would need to get to compensate for the mass that semi has would be pretty outstanding. So mass and speed both play an effect on the total energy the object has. So make sure that you remember that those things affect it. A lot of students seem to think that speed is the same thing as kinetic energy. It is not, but it does have a role in telling you how much energy something can have. So another thing you can think about is, who do you think Mr. Severson would rather be tackled by, a toddler or Dwayne "The Rock" Johnson? The answer is a toddler, because a toddler can't take Mr. Severson down. The Rock would totally destroy Mr. Severson because he has a ton more mass over me. So if you go to your table, there are 5 examples of kinetic energy, and we're going to talk about some of them. The first one is mechanical, and this is our most typical type of kinetic energy. So it's just the energy from a moving object. So think wheels turning, if you're running, throwing, jumping, if you've got gears turning, anything where the physical object is moving is a type of mechanical energy. Sorry that I don't have a picture here, everyone. So, make sure you have those examples down, and then try to think of an example of mechanical energy and try to draw a picture of that. Our next big type is called thermal energy. Most of you should have a pretty good understanding of what thermal is because you may have heard of a thermos or a thermometer. Basically, it's energy that is released from the vibration of the particle in matter. So when we get to a unit called thermal energy next, we're going to learn that thermal energy is just the vibration of all the atoms in an object. Now, this feels like something very specific to us called heat or things like that. So we have a couple examples of thermal energy. If you want to add something on here that's not on this list, please go ahead. First one is fire. Personally, I think all of you, when you think of thermal energy, I'm pretty sure fire is going to be one of those things that come to mind. You could also think of things like heaters. You could also think of things like friction. When two things rub together, you get a burn. If any of you have ever gotten a friction burn, like you scraped your hand against something, I tend to get burns if I fall off my bike and hit the pavement. Like my arm just feels warmer after that because it rubbed up against it. Another thing that can go with thermal energy is also cooling. So not only do we have an increase, but also decreasing the amount of heat that we have. So that's thermal energy. Make sure you have examples and pictures written in. Then we have something called radiant energy. So radiant energy is energy that moves as waves through space. If that sounds confusing at this point, please don't worry about that because radiant energy we're actually going to dive into next week. But the biggest thing that you can think of this as is light. All light on planet Earth and in the universe is a type of radiant energy. It's energy that's being sent through space and everything as this wave. You can actually see this a little bit in a combination of thermal energy. You can actually see the heat producing wavy lines, and that causes the light to bend and give it a little bit of a wavy motion as well. If you've ever gone to a hospital and gotten an x-ray taken, that is also energy that's used. Part of thermal energy with heat, there's a part of light called infrared that goes with that, and that's also radiant. And we also have ultraviolet rays that come from the sun, and all of those things are examples of radiant energy. All right. Another type of kinetic energy that we have is sound energy. This is very similar to radiant, as you have energy moving as a wave through water. Something that you can think about with this is if you have ever dropped a rock in water or in a pond, you'll notice that the waves ripple out from that source. Sound is the same idea. You have a source and it causes energy to ripple out. So for examples with this, you can think of places where you've heard that generate sound energy. So things like stereos, headphones, objects clanking, basically anything that makes a sound. And do your best to draw a picture for how this one would work. And then our last type of kinetic energy is called electrical. This is pretty easy. It's energy that uses electricity or an electric current. So examples of this is anytime you use a charger, anytime that you use electronics like phones, computers, TVs, video games. Those are all things that are using electrical energy because it's just letting it flow through. Lightning's another great one because you build up so much energy in the atmosphere, especially during a storm, that it's all released at one moment as a giant charge and current as it flows towards the ground. Hopefully not at you or anything around you. Okay, once you have your table filled in, you should have this part here at the bottom. So let's kind of wrap up a little bit with some potential and kinetic energy. And I apologize for some of the typing here. I guess this didn't get fixed by spell check for some reason. So what you're going to do is in each box, you're going to label where the potential energy is and where the kinetic energy is or will be. So you're going to need to go back to your notes. You're going to need to reference them and take a look at this guy with the bow and arrow. Where is the potential energy? Where is the kinetic energy? You can either write it here in the side. You can write potential and kinetic energy and draw arrows to where it should be. Then you have a battery-powered flashlight. You need to describe where the potential and the kinetic energy will be. Then we have that roller coaster that's on the very first page of your potential energy notes. And then I want you to create your own scenario where potential and kinetic energy is and will be. And then your final question at the end goes back to that concept of matter and energy. So let's go back to our two skiers. Let's say you have two skiers with the same equipment and starting point. Skier 1 has a mass of 60 kilograms and skier 2 has a mass of 80 kilograms. Which one is going to have more energy going down the hill? Now, I said who's going to have the most energy. I told you before that speed and energy are not the same thing. So make sure that you revisit that and then write this down so that we can review this as a class the next time that I see you. If you have any questions about anything that we talked about, please shoot your teacher an email. But yeah, nice job. Please check out some of the extensions in our extension folders. There's a really great roller coaster game that I suggest that you all try. There is a scoring to it, and there is a maximum score you can get of 3,000. But I'm going to tell you, I've only seen one student ever get 3,000 on that roller coaster game. So good luck. Check out some of the other videos and games that we have, kids, and we will see you in class. Take care, everyone.